Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Okay, guys. So now I think we should understand how Kubernetes works. In another way, we say let's know about the Kubernetes architecture, right? So as part of this, we need to know masters, what is masters, what is nodes, what is the pods, what is services deployment, and many things. So guys, let's look at the Kubernetes with a big picture view. What is a big picture? So we say Kubernetes is an orchestrator for microservice app. Microservice app. So last time I stated Kubernetes is a container orchestrator. That was okay. But the Kubernetes is an orchestrator for microservice app. What does that mean? I am trying to understand. So guys, do you understand what is a microservices first? How many of you understand the microservices? Can you please help me here? What is a microservices? What is a microservices?
Breaking services into the smallest working unit.
Yeah. So guys, see the evolution of computing architecture. I mean software architecture, sorry. And again, I have many videos on this topic. DevOps, microservices, SOA, Agile and all at my channel, DevOpsSchool, you can check it out. But right now, see here, with the evolution of the internet, okay, we are migrating the software from monolithic to SOA. Okay, SOA means service oriented architecture. Service oriented architecture means web server, app server, database. Monolithic means one of the monolithic software which you are using right now in your laptop is MS Office. Hundreds of things is there bundled together and you are using it. But web services, it can be a DevOpsSchool.com. Apps, web server, you have Apache. App server, you have a PHP. Database server, we have a MySQL. But now guys, we are moving to the microservices, SOA to microservices. This is not a service anymore. Microservice. So what is the microservices? Why it is happening? And it is happening because of only one reason, and that is we are using cloud-based software a lot. Gmail, WhatsApp, Facebook, Instagram, LinkedIn, HDFC Bank, ICICI Bank, Paytm, this, that, a lot. And second important thing is we are not allowing the application to be having downtime even for second. Yes, I repeat, second. You don't want the application to be down for a second. So think simple. If your all of your applications is bundled together in one place, then if something goes wrong, even one functionality can break everything. So of course you'll have downtime. So let's not do that. Let's have a microservices. That means, okay, maybe there's a problem in one services, but rest of the services will be up. So something similar. I'm not going to teach you microservices, but I'm just giving you the highlight of it. So think guys, let's say this is the one of the product which we have, and you have a 200 features here. One feature, 20 feature, 30 feature, 40 feature, 50 feature, 100 feature, 200 feature. Now for this all 100 features, we need how many people? 100 people to develop test operations. 100 people means too many people. So one person has to talk to 99 remaining people to collaborate their work of the development, testing, and operations. Too many communications, too many emails, too many processes, too many sync up meetings, and this, that, and all happens. You know that. You are a dev team, you are a QA team, you are operations team, you are a manager, you are architect, you are this, you are that. So many meetings, so many emails, you waste a time actually. So what is required here? What is required? So whatever the software you have a 200 functionality, let's do one thing. Let's break it down. So here, make it separate this one, because REST API is now through the REST API, you can run the application in a distributed manner. Make it separate. Make it hundreds of microservices. I repeat, one service convert into the hundred of microservices, and one microservice is equal to one feature. So now how many teams you needed, guys? Earlier in SOA concept, we have hundreds of developers, hundreds of engineering team. Now we don't need hundreds of people. You just need to manage one microservices. So how many people you need? 2 people teams. 1 people team. Yes, it's possible. 2 people, 3 people. See here the size. Now you tell me, do you really need to send an email between the 2 people or 3 people? Do you really need to have a meetings, specific dedicated meetings? No. You are saving so much of time. These 2 people now will do the development. So testing and planning and operations, all things together. That is, we call it DevOps in real definition. Many people have manipulated DevOps in a different way, but actually this is the DevOps. A person who can code for the software. Now, the person who can plan for the software, or maybe the planning might come from someone else also, the client also, the person who can code for the product, for the software, or the person who write a code for the software, or the person who write a code for testing the software, or the person who write again code for operations. Everywhere, that's just so only thing is needed is code. Do you code? Coding for the product, coding for the testing of the product, or coding for the operation, that is called DevOps. So we need one microservices, one feature, 1 or 2 people, and these 2 people will do everything from scratch to start to end. So like that, we want to migrate. Every organization wants to migrate in these manners over the evolution of the internet, 4G, 5G, and all this stuff like that. So every teams will become a independent. Every team will become independent. No need to send an email. No need to have some process, long waiting, wastage, and so many things, so many problems we have. So I have a very good recording on the DevOps side at my channel. So please look at this. Okay. So all this thing. So now the question is, okay, fine. It looks very nice. I can hear very nice keyword actually. One big services we migrated to convert into the 200 services. But the question is, in this scene, who will manage 200 services now? Remember, 200 services, who will manage? There should be management tool also, right? To manage all the 200 services. Something like a registry of services. This something like that. The place where you can find all the services. The registration of the services, removal of the services, all this thing. So in this fashion, if you convert the 200 microservices, your software may not be down. All functionality may not down. In this case, let's say one functionality has a bug, so only one will be unavailable. Remaining software will keep working. That's the reason you might have seen many times, if you open up a HDFC Bank or ICICI Bank, some of the part of the functionality has some problem, but rest of the still is still working. Now, what is the beauty here is in the microservices, there is a bugs, right? So here you can fix within a minute, within a hour, within a day, and you can roll back, roll out faster. Roll out can be done faster. Roll back can be done faster. And you don't have to test entire functionality. You have to test only your software. So earlier you were testing entire day for the one software. Now you are doing the testing in just 5 minutes. because every microservices will do the certain post, certain get. Simple. CRUD operation. Every microservices has certain rules, what to be exposed, what to be receiving as inputs. That's all. So this contract, if you are respecting, then everyone is working in this manner. But the question is not that. Microservice is very good, but the question is who will manage these 200 services? So first of all, guys, when you got a container technology, managing a Kubernetes, container technology, then creating a container, scaling the container and all is become so easy. But the problem here, we have 200 services, and each services, I said one services, you have 20 containers. Think about it. Or I'm just giving you a small scale requirement. One service, we have a 20 containers. So 200 services, you will become a, let's say 200 services like a 4,000 containers you are running with. So now the question is, who will manage 200 service? Do you have any tool? The answer is here, guys. Kubernetes. If your application is in the container, then managing the service. When I say service, that means I'm talking about this service, guys. Where is the image? I lost it. I'm talking about this one service. Like that, you have 200 service in the container technology for your applications. So who will manage it? Who will orchestrate it? Kubernetes. Yes. So Kubernetes is an orchestrator for microservices app. Are you understanding, guys? What are the benefits you are getting from the Kubernetes when you are moving to the containers technologies and all? Guys?
Yes, Rajesh.
Great. So guys, Kubernetes is an orchestrator for microservices app. Look at this image. This is one of the football ground. I need some input from you here. And you have a team here, multiple team. So guys, here you have a soccer ground, football ground, and multiple teams are there. So anyone would like to comment on it? What is the end goal for the team, each player, sorry, each player? What is the goal? What is the objective for each player? Tell me.
To contribute in scoring goal.
So something like that, right? So if you think, or if I think, okay, the players, the goal is to make a goal, simple, nothing else. So guys, if you set the each player objective to make a goal, then what each player will do, you know what? See that. They'll be near to the goal post. They'll be near to the goal post. Everyone will try to achieve their objective, and they will try to achieve the objective by being near to the goal post, and they'll try to make a goal. You know that like this, if you play, you will never win. You'll never win. So what do we need? Then that is where the manager is coming. Sometime you call it a manager, sometime you call it coach. I am from the Hindi medium school, so we used to call Master G. Okay. So that is where the master comes into the picture, manager comes into the picture, and coach is coming into the picture. And manager says, listen, I know each one of you. Think about it, simple. Coach says, I know each one of you. I know each one of your capabilities as well. So let's do one thing. Let's play in this way. Don't make your objective to make a goal. No, you have no objective to make a goal. What is your objective then? Just keep passing a ball to each other, because you cannot run faster than ball. If you run, you get tired. If ball will run, ball will never get tired. Ball can run 20 or 30 times faster than you. So just keep passing a ball to each other. Coordinate well And that is where there will be one strike point or two strike point at the end of the near to the goal post, and they will make the goal. So your responsibility is what is your objective? Not to make a goal. Your objective is to just keep passing the ball till the objective is served. Here, this who is controlling everyone then here? Manager, coach, master G. Correct? So everyone is controlled by manager. Now, the moment if anyone who's disobeying the instructions from the manager, then immediately he will, throw you out of the ground. You know that very well. And that is a why, each player play well, fast, better. So in the FIFA also, if you notice, actually, the team wins not because of you have a best player in your team, best player of the world in your team, but the team wins those who coordinate well. Even though you are not a best, but if you can coordinate well, you will win. Okay, so now you must be thinking why we are adding here. So now, guys, convert all these. Think simple. Think simple. Convert these all player as a one microservices. Yes. Remember, to serve the objective in the software, let's say you want to do some purchase on flipkart.com. So what do you do first thing? First, you do the login. After that, you do the browsing of catalog. After that, you adding the product to your cart. After that cart, from there you do the transaction, payment, you get the confirmation, then you do the in-house services. I mean, in interior, I mean, what do you say, hidden services like that warehousing, delivery, postage, confirmation, all this, so many things happen, you know that. So guys, to serve one request to the end, multiple microservices will coordinate with each other. Some of them will be in the front end, some of them will work in the back end. So convert each of these players as a microservices. And microservices, what they pass? Request and response. Each services receive some request and each services give some response. Simple, you know that. That is how they here convert the ball into the request and response. And what you keep doing it, passing the request and response to each other. And the well you transfer the request and response, the transaction will be completed. But the question is, if you have 200 microservices, think about it, 200 microservices, who will manage it? There should be some management capability to manage all these microservices. Do we have any manager here? Do we have any coach here? Do we have any master G here? Yes. Kubernetes can manage all the services. It could be HTTP, search, auth, MySQL, KB store, log, load balancer, any kind of microservices you have in your applications. Kubernetes will manage those things. That's the reason we call it Kubernetes is an orchestrator for microservices. Now look at this here. Load balancer to the HTTPS to auth, search, this, that, and all. So all this, they're passing request and response, but still management is done by, all the microservices management is done by Kubernetes. And that's the reason we call it the Kubernetes is an orchestrator for microservices. One of the interesting point which you can see here is, look at this here, HTTP service specifically. HTTP services, one is running in the node 1, another one is running in the node 2, but the behavior is still same. You may be running in any node, these services, see here, HTTP is one service. You may have a 2 or 2000 container or 20 container, but the behavior will still remain same, no matter which node it's running, because of Kubernetes. So guys, with that in perspective, that in place, let's talk about Kubernetes architecture. Guys, in the Kubernetes, we have Kubernetes cluster. Yes, look at this image very carefully. You have Kubernetes cluster. So what it contains? Kubernetes cluster master node. Master, what is a master? Master is your manager. Master is your coach. Master is your master G. Who manages what? Who manages multiple node? What is a node? Node, it can be your physical machine, it can be your virtual machine. Master, what is a master? Master manages the node. Master, it is also can be a physical machine or virtual machines. In a short, you have a cluster of node. Some node is behaving like a master, some node is behaving like a node. Okay, now master controls everything, every node, but who controls the master? One package controls the master, which is coming from outside. Now the guys, master do everything, but master is controlled by the package which is coming from the outside. And who create this package? Anyone would like to comment on it? Who create up this package? Guys, are you there?
Developer.
Operations team.
You see guys, you are creating this package. You can be a developer, you can be a QA, you can be a DevOps, you can be operations. You create a package, because if you don't create a package, then what is your responsibility? What is your job? Then you have nothing to do, because everything is done by Kubernetes in the operations. You have nothing, no work to do. So what is your job? Whether you are dev, QA or operations, your job to write Kubernetes packages. Remember in the Docker, I said your job is to write good Docker image. So same way in the Kubernetes, your job is to write good packages, nothing else. Write the packages, give it to the Kubernetes, forget about it, go and sleep. No need to have any sort of things like a downtime or something like that. So guys, in this picture, if you look at it very carefully, you have a multiple master, one behind another one and all stuff like that. Why we have a multiple master? Because here what happens, entire Kubernetes cluster, mind it here my statement, entire Kubernetes cluster is managed by master. And because of some reason, master node is not functioning well, then imagine what will happen. Whole cluster is down. Whole cluster is down, whole application is down. So because of that reason, we have a multi-master cluster, minimum starting with the 3, 5, 7. I have hardly seen 7. 3 is a most. So one should be down, so second automatically act like a master, or third will automatically act like a master. So here in the cluster, you need only one master to act on and manage all the nodes, but you may have a multiple master to make it HA, high availability of the clusters. And multiple nodes, anyways, you have a multiple nodes. It can be one node also, it can be multiple nodes also, depends on your number of containers what you want. So guys, what I have learned so far from this image is there is one Kubernetes cluster. In the cluster, you have a master and node. You can have a multiple master, you can have a multiple node, depends on the requirement. And the master is controlled by packages which we write, and master control all the nodes, which you can see it here. With that, guys, master is in charge, and node who's the really doing the work. Work means what? Always whenever I state work means running the container. Mind it here, I said running the container. But now guys, here if I look at the image, I see something different here. Here I see that the packages is being deployed to the master who's in charge for the entire cluster. Master manages the node, multiple node, in this picture 6 node. But I see that node has one pod. What is pod? I don't know. But guys, inside the pod picture, can you see the icon? What is the icon? What is this icon? Anyone would like to tell me what is this icon?
Continuous icon.
Ah, yes, that's the icon belong to the container, guys. So please remember all the time that icon, wherever you see, that's the icon of the container. So okay, fine, I understood that master is a node, Master is can be VM or it can be physical machine. Node can be VM or it can be physical machine. Master manages all the node. Node is the place where you run the container. Master manages all the node. Node is master is managed by the deployment package which we write. That master and node we call it a Kubernetes cluster. But the question is, node has a pod which I don't know, and but pod has a container which I know very well. Container I know very well. Docker container I know very well. But what is a pod? I don't know. But the problem, the things which I know is pod you have inside a node. But what is a pod? We don't know. We'll figure it out later. But remember, this is your architecture. Master, node, together, we call it cluster, and node has a pod and pod has a container. So if someone will ask you in a Kubernetes, where is a container? So you can tell inside a pod. But where is a pod? Inside a node, or you can call it a worker. Okay. Now look at this image, guys. Master. Okay, so in this whole things we have a 3 component: master, node, and deployment packages. So first we'll focus on the knowing master, then we'll focus on the knowing the node, and then we'll focus on the deployment packages. Okay, so one by one. So let's focus on the master. So what do we call it? Masters. So guys, here masters, the one which you have right now, we also call it the Kubernetes control plane. Yes, the Kubernetes control plane. What is a Kubernetes control plane? So guys, let's understand this. So guys, here the master node which can be a physical machine or virtual machines, the master node has to be a Linux. It can be a Fedora, Ubuntu, CentOS, RHEL, all stuff like that. It has to be Linux and it has to be 64-bit. Now guys, master manages the node. Node, as per this image, all the nodes you can see in Linux, right? But you know what? From the 2019 onwards, means when I say 2019 means recently, Microsoft supported the worker in Windows for the Kubernetes with the supporting the container technology. So that means from 2019, Windows 2019 onwards, the node can be also in Windows. Yeah. So master has to be Linux 64-bit, but node can be Windows or Linux 64-bit. Okay, so it can be Linux, it can be Windows also. Make sense? So this image has to be modified, little bit of it. Are you understanding it, guys, so far?
Yes.
Yes.
So guys, master, when I look at the master very closely, if I go deep dive into the master primarily have a 4 component. Okay, anyone guys remember the Docker component? What was the Docker 4 components? Can you tell me? I just recall in my mind, so I thought let me ask you, what was the Docker components?
Docker engine,
Anyone?
Docker image,
Docker engine,
Docker engine, Docker image.
containerd.
No, that's architecture, sir. How Docker works. I'm saying components of Docker. So Docker engine, you correctly said. Docker image, you correctly said. What is the
file system.
Registry,
registry? And then fourth one,
Docker container.
container. Yes. So that is not in related here, but still ad hoc basis, just I ask how much you remember, because if you don't understand container, then we are wasting time here with the Kubernetes. Yeah. So coming back to now on this topic, guys, master node has a 4 component, basically 4 software running. Okay. Remember what you are trying to understand from me. You are trying to understand how Kubernetes works, how Kubernetes give you so much of flexibility, and for that you need to know these 4 components. But before that, can be a master, can be a HA also, multi-master. You know why? One master get failed, second master get failed, third master should be HA. High availability, it can be HA. So here images, like guys, this is a very interesting image. Now if I see that very carefully, focus on the center of the image. Master node has 4 components. Which are those? I will discuss little later, but here I see master manages the node. It can be Windows and Linux as well.
To watch our complete session, enroll for our premium membership. Click onto the join button and enroll yourself with the best suited option.
But left side extreme top, if I see node has a pod and pod has a 2 container. Okay, so this is interesting. Earlier I learned node has a pod and pod has a 1 container. But here I see node has a pod and pod has a 2 container. And the second side, opposite side, I see node has a 2 pod and each pod have a 1 container. That means, okay, fine. What is the pod? I don't know. But the pod is resided in the node, and node has pod. Pod has a container. Pod may have a 1 container. Pod may have a multiple container. Node may have a multiple pod. Node may have a 1 pod. Are you getting familiar with this or not? What is a pod? We don't know, but still I don't know. You may have a multiple pod, you may have a single pod, you may have a 1 pod multiple container, you may have a 1 pod 1 container. It's up to you. Are you understanding it or not, guys?
Yeah.
So guys, next question is, let's understand the 4 important component of the master. In short, when I say component, that means 4 important software of the master. Let me repeat, guys. If you don't understand this architecture, it will be the entire remaining 2 days will be wasted. So I would request you all to focus on it. So guys, master, you have a 4 component. One of the component we call it API server. Okay, cool. API server. So guys, all of you, do you understand what is the API? What is the API? Anyone would like to tell me what is API? It's API server. So here there is a 2 words. So guys, whenever what I do, whenever I want to understand any functionality, so I try to break the word itself. So this is a API, this is a S server, API server. 2 word is there. So what is the meaning of API? First, can you tell me?
Basically, a application providing you an interface to do a process.
So guys, you said correctly. So guys, in a simple way, if I put it in my keyword, my word, so basically API is one function. I repeat, API, one API means one function, and that you can access it from the remote machine through REST API, through HTTP or something like that. Remote machine. Okay, I can access this API from anywhere and I'll get only one function. And this function, you know what you can do? You can do create, read, update, and delete. That means this function, if you want to create or read it, update it, or delete, CRUD we call it. Okay, so this is the one of the APIs, which is a one functionality, one functions, one feature. Now guys, server, you know that we've been using this keyword since so many years. So when I combine these 2 words, API server, look at this image here, API server, what does that mean? That means this API server, if I put it, this one is a API server. That means in this server, you have a multiple API. 1, 2, 3, 20, 30, 40, 100, multiple API. But guys, the problem here is, if I tell you, sir, let me ask you one thing, sir. If you have a 200 features, and if I give you 200 API endpoint, will you remember this? Let's say I'll give you 200 URLs. Think simple. I'll give you 200 URL. Each URL consists of one API, and each URL you can do the CRUD, no problem. But will you remember all this CRUD? I mean, this URL? Tell me.
No.
You'll get frustrated, don't you? Correct?
Yes.
So no frustration, guys. Put all the URL into the API server. In a technical word, we call it API registry. Okay, a registry of APIs. Okay, all the API registered at one place, and now you can access from the only one IP address, and you specify what API kind and only one IP address. Just you want this API or this API or this API or this API, hit to this and say what you want here, what you want to do, CRUD, what you want. It's become very simple. So now guys, what I'm trying to tell you here is very simple thing. Kubernetes, you have hundreds of functionality. I repeat, Kubernetes, you have hundreds of functionality. All this functionality, they converted into APIs. Yes. So you must be wondering, what is this? So, I'll tell you one statement. Please hear me out clearly. The Kubernetes architecture itself, I said Kubernetes software. Forget about this, what is being used for. But Kubernetes software itself is one of the best example of microservices. Yes. Kubernetes is not monolithic. Kubernetes is not SOA. Kubernetes is a microservices based architecture. So they have 200 functionality, but where they do keep it? They keep it in API server. So if you want any functionality, hit the API server, get the CRUD operations done on that particular API, and be happy. So what is API? It's in the official terminologies. Guys, API is the front end to the control plane. Control plane means the master. Master, remember all the time. Master control everything in the cluster. And if you want to reach out to the master, how can you reach out? API server. There's no other way. I repeat, there is no other way to talk to the cluster but API server. So API server is a front end, is a receptions for your cluster, reception. Without reception, you cannot get into the office. Your office is a cluster. You want to go inside office, you have to cross the reception, and you have to cross the reception, you have to register it over there. So basically, API server is a front end to the control plane. How can you access this API? Basically this API server is exposed to the REST APIs, so you can access through HTTP also. REST API, you know that very well. Those who have no understanding about the REST API, please go and study a little bit of it, you'll get it. Now, how do you send this request to the API server? How do you send the request to the API server? More or less, most of the API which is exposed in the world so far, most of these are consuming a JSON. So this API also consumes the JSON because it's a fast and very reliable. So guys, yes, you have to write a JSON file, send it to the API server for the API which you want to get the functionality with. CRUD means basically CRUD, and then get your work done. So guys, the one component which we have in the master out of 4, one is API server. Guys, did you understand all of this or not?
Yeah.
Guys, I would like to show you one thing here. Please just give me 10 more minutes. So guys, here let's say you want to tell something to this guy. Okay, so of course you will tell some instructions through your audio capability. By the way, this API server accept the JSON only, but they will listen some, I think it's a sound, right? Sound vibration. So you will tell something from your audio device. Audio device means your mouth. So which will be the input here? Who will be receiving that input if you instruct something to this guy? Tell me, all of you. Who's the input? What is the input here in this? See here, your face is your control panel for your body, and you want to get some work done. So which is your input here? Tell me.
I mean,
Taking
to
the
go
input
to the ears, to the brain.
Eyes.
here, no? Guys, I say something to
Yeah.
you. You hear
Yep.
from your ear, right? Not from your eyes, correct?
Correct. The ears and then the
Right.
brain.
Right. Now, guys, this you hear from ear, the sound vibration which is received, well received by your ear. I don't know what qualities we have in the ear. I don't know, but it received by ear. And where you store it? Tell me, where do you store it?
In the brain.
In the
Memory.
brain, in your memory, guys. This is the very well defined architecture for the human beings also, right? So you receive something and you store something in that your memory. Okay. So guys, you need to have a memory. Why memory? Because of persistency of your information, persistency of data. So same way, guys, if you request something, think simple. If you request something through API server, this is your ear, API server is your ear, is the front end to the control panel. There should be some storage. So here we have a storage. Anything you send, repeat, look at the arrow here. Okay, anything you send to API server stored where? Cluster store. What is cluster store? It is your persistent storage. It is your permanent storage where everything what you sent or what cluster has it is stored. Simple. Everything. That means in a simple way, if I tell you everything you have in a clustered store, same way, whatever your experience from your childhood till now, whatever it has experienced, you have experienced, everything is stored in memory. So same way, whatever you cluster has experienced so far, inside from outside, it has in the memory. That's in a cluster store. But the question is, okay, fine. Tell me, Rajesh, this cluster store is powered by what? What tool? This storage is powered by what tool? Is it powered by MySQL? It is powered by the DynamoDB, MongoDB, MS SQL, Oracle? No. What exactly? No. This is powered by etcd. Yeah, this storage is powered by etcd. Now etcd itself is one product, free product, open source product, based on the distributed concept. That means you can set up a multi-cluster etcd server itself. It is a consistent and watchable from many places, and this is a source of truth for the cluster. What is that? What does that mean? Source of truth means if the information you have in the cluster, that you have in the, sorry, the information what you have in the cluster store, you have in the cluster. If that information which is not in the cluster store, that is not exist in the whole cluster. Simple. Okay, so you have to back up a plan. You need to have a backup plan for it, because see here, think in a simple way. See, if your hand is gone, we can get replacement done. Nowadays technologies is there. If your eye is gone, you can get that eyes back. Rest of the things also probably you can get it. I'm not very medical expert, but I feel, I mean, by reading the news. But if your memory is gone, which you have a experience from last 20 years, 30 years, 40 years, if that is gone, you will not get back. You'll have to experience again. So yes, you have to backup plan for it. So only one thing which you have to take a backup for, that is your memory. So guys, the second component of the Kubernetes is your cluster store, is persistent storage, which store all the cluster state and configuration file powered by etcd. And I would request you all to go and study a little bit more about the etcd. It's wonderful, one of the open source database, a persistent database, key and value based database, which is growing a lot nowadays for the many of these tasks. So guys, did you understand the second component of this master? All of you?
Yes.
Guys, what is the third component? So guys, if you look at this here, third component is controller manager. See here, read it carefully. Again, I'm requesting you to all to break it down, this keyword. It says controller, Q, forget about Q means Kubernetes. Controller manager. Controller means what? Control something. And manager means what? Manages something, simple. So here if I see that controller which controls something and manager which manages the multiple controls, that's the reason we call it controller manager. Simple, very simple. Okay, look at this here. Third component I'm talking about, controller manager. It is a manager for multiple controller. Think simple. It is a manager for multiple controller and each controller controls something. So now let's correlate here. Tell me, in your body, in your control plane, this is the one which I'm showing you is a control plane basically. Which is your controller?
Brain.
Tell me. Controller, I said controller. Control something. Monitor something. Monitor. Let's use the simple word. Monitor something.
Eye, ear.
Eyes monitor.
Eyes monitor. See here, sir, you said now is night. You hear, you send to the memory. Memory stored. Okay, this guy is saying now is night, not a day, but your eyes will see. Correct. Eyes will monitor your the environment and experience. Oh no 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 no. This is not night. This is a day. Who will inform you? Who will inform your mind that it is not a night, it is a day? Your eyes, correct? Right? So guys,
Yeah.
who's
Yes.
a controller? Controller is your eyes. How many controller you have, guys? For the God, given by the God, we have a 2 controller, by the way. 2 controllers, see here. So now this eyes is a controller manager. This is a 1 controller. This is a 1 controller, 2 controller. Maybe the God Shiva has a 3 eyes also, right? And I think everyone has a third eyes also, but it's hidden, I guess. Right? So this is your controller manager. Controller manager, which controls something and update back to what? Memory. Simple. So now guys, look at the arrow here. Your controller manager talk to what? API server, and API server update back to the cluster store. So everyone is talking to the API server. Remember, cluster store you cannot talk directly, only through API server. So guys, what is a controller manager? Guys, controller manager has a multiple controller. Each controller controls something like a node controller. Node controller, what will do? Node is up or running, up or not, up or not, up. This node is connected. Like master manages the multiple node, right? So which node is connected or which node is not connected is controlled by node controller. Many controllers, so we have it: endpoints controller, namespace controller. What is the endpoints, what is the namespace, and all slowly you will get comfortable with. But in short, what is going on in my cluster is controlled by controller, and this controller is managed by controller manager, which helps you to watch is for the changes in the cluster and maintain the desired state. For example, I have been saying so many times, who will make sure that 100 containers you wanted, that means 100, not a 99, not a 101. Who will control? Controller manager. So this controller manager will keep controlling. They will create one controller, and this controller will keep checking 100, 100, 100, 100, 100, 100, 100. The moment it become a 99, it will be a problem. It will immediately report back to the API server saying that I got only 99 or 101. So guys, these controllers always runs in the loop. It never stop. Always controller stop. You know what will happen? Every cluster is having problem. So it never stop. So guys, see here. Now you receive something. Think simple. You store here. Monitor everything. And now based on that, if you want to respond something. I said respond. You're not doing any work. You have a hand, but you're not doing any work. You will respond something. Or maybe let's say you're a supervisor. You will say, okay, let's say in simple way. Someone said, my manager said to me, let's say there's a senior manager, there's a manager, and there is an engineer. So senior manager said to manager saying that, okay, get this, Mr. Manager, get this task done. The manager will tell to the manager will hear, manager will store that thing in the memory. They will see the status of the work, and then if something is mismatching, then he will talk to his engineer, right? He'll schedule the work to the engineer saying that, okay, you do this, you do this, you do this, you do this, let's complete all this stuff. Why? Because this is the whole work has to be done. So who will assign the work? I said assign. I'm using the keyword very carefully. I said assign, not doing. I say schedule the work, not doing yourself. So guys, in your body, on your face, on your control plane, who will assign the work? Tell me.
Mouth.
Mouth will assign.
Guys,
Yeah.
you have only one mouth, mind it. You have only one mouth. So your mouth will assign the work. So if you think so guys, here also in the Kubernetes cluster, we have one mouth. His name is Kubernetes scheduler. What exactly they do? So guys, this scheduler keep watching API server. Look at the arrow. Keep watching API server. What happens? For what? What scheduler is keep watching API server for what? The request from what? API server. For what? New pod. Remember, what is a pod? I don't know. But I got to know in the node, in the worker, you may have a multiple pod. Each node, each pod, you may have a single container or multiple container. That I know. But what is a pod? I don't know. But here what will happen if you want to deploy some pod which has a container ultimately? So here what will happen? Let's say human request. Think simple in the full scale. Human requested to the cluster stating that I need a 10 pod. 10 pod, ultimately you have a 10 containers. You may have a. So 10 container. Now API server stored that in the cluster stored. Controller reported back saying that, okay, boss, you have a 0 containers, or you have a 5 these containers already, this 5 pod already. So now 5 remaining has to be completed, right? So what will happen? API request, API server don't talk to the worker directly. They assign this work to scheduler. Yes. API server say, boss, can you please not create, assign this work to create a 5 pod to the node? And scheduler is very intelligent. Remember I said, what is a Kubernetes? I said one statement, workload placement. I hope you remember. So workload placement is done by scheduler. So guys, what exactly it has? These guys keep watching API server for the new request, new pod request, and based on the request is assign its schedule. It's not never doing the work. It schedule the work to the node. I repeat, node worker. Based on the many conditions. Scheduler has many condition inbuilt. You can influence these conditions also. What condition? So scheduler will have a condition like affinity. Affinity means, let's say my manager thinks I'm a very bad engineer. Okay, so he may assign work only to me so I can improve. Or anti-affinity. Anti-affinity means anyone can do in the team, I have no problem. Any random people. So it's like that. So assign work to the nodes. Affinity, special worker or any worker, anti-affinity. Constraints means the work should be assigned to the node only if you have this much of RAM and this much of CPU. or many other constraints are there. So here what I'm trying to tell you is a Kubernetes scheduler, kube scheduler is the fourth component of this cluster, and their work is to just to listen API server for what? New pod request, and based on the request from the API server, they schedule the work to the worker based on the multiple condition. That's the reason we call it scheduler. Scheduler assign the work. So guys, in short, all these things together, we call it master, or aka the control plane. Guys, are you understanding it so far? Are you understanding it so far?
Yes.
Yes.
So guys, this is the only master, right? Remember. So in a simple and summary way, what is a master? The control plane components. So you have a 4 component: API server, cluster, store, scheduler, and controller manager. API server is central. It has to be central. Simple interface. Anyone can reach it through the RESTful APIs, and it updates etcd. Cluster store, what is this? It's a persistent stage, store the data in the key and value format, powered by etcd, and you can watch it from anywhere, wherever you want it. Okay, scheduler, it watches API server and help you to schedule the work. It's not doing the work. Remember, schedule the work to the node based on the resource and resource constraint. It has a multiple rules. You can customize it. Then you can influence this also. And controller manager, which always runs in the loop, which has a controller, multiple controller, each controller controls something. Basically, it helps you to manage the life cycle function for the pod and desired state, whatever you have. 100 container, 100 pod, 100 pod means 100 pod, like that. It watches and update the API server. It watches the API server and update the API server and replica set. What is a replica set? I'll tell you a little bit later. So in nutshell, this is a little bit broader perspective of the Kubernetes architecture. Look at it very carefully here. Master, on top you have a 4 component, and then how this works I have explained it to you. But who control the master? Look at that, your laptop. So you have a laptop, and in your laptop there is one tool we have. Which tool? kubectl. Yeah. So in your laptop, we will call it, throughout the session we will call it workstation. Remember, please be familiar with this keyword. Your laptop, I will call it a workstation. Master and the worker. Worker is you can call it a worker node. Master, you can also call it master node. Master, you can also call it a control plane. So please do not get confused. These are the multiple terminologies being used in the world of Kubernetes over the period of time throughout this Kubernetes evolution, but we have to get comfortable with it. Master is equal to Kubernetes plane. Worker means node worker. Master node, it can be this one. And workstation is your laptop. What we have in the workstation? kubectl. kubectl, you create what? You create a package. Which package? In JSON. You send to what? API server. API server stored in the cluster store. Controller manager will report back to API servers about the state of the cluster, because it keep monitoring everything. And based on that, what you have in the cluster stored, and based on what it reported by controller, if anything mismatch happen, scheduler send the request and schedule the new work or whatever it is. And node has a pod has a container. So guys, are you understanding it so far? All of you.
So one question, yes, it means that the nodes are like always dedicated, right? So the work is given to the nodes, right? I'm interested to know, like, there is no way that a new node is created, right? From the kubectl, like,
Kubernetes job is to not to create a node. Remember.
yes, it
Node
means that we will
Kubernetes.
have a dedicated nodes when we start this, right? Or we can add and manually we can add or remove the nodes as a separate task, right?
Not
But
manually, it can be automated actually. Let me tell you
yes,
who
yes,
will
but
create
as a separate,
who will
yes,
create a more node. If you're on a cloud like AWS, auto scaling group, based on the CPU utilization of the existing node, you can add a more node or reduce the more node. These are the work will be done by your cloud platform, not a Kubernetes. Kubernetes manages your containers and pod. Who manages the node? Node is managed by cloud platform like AWS, Azure, Google Cloud, or VMware. Make sense?
Yes, thanks.
So now this is the stuff. So guys, here so far this is the stuff. So guys, we have a one more topic, which is you have to know about the Kubernetes worker convenience. Okay.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.